Picture this, a vast, dark expanse of nothingness. That's our early universe. Scattered throughout this cosmic void are tiny specks of dust and wisps of gas. These are the building blocks of everything we know, including our solar system. About 4.6 billion years ago, a nearby star exploded, a supernova. This explosion sent shockwaves through space, hitting our cloud. The shockwave compressed our cloud, making it spin faster and faster. It got hotter and hotter until finally, it ignited. This was the birth of our sun. From the spinning disk of leftovers, our planets would soon emerge. Now, let's talk about a force that's literally brought us all together: gravity. In our spinning disk of dust and gas, gravity became the cosmic choreographer. It started pulling particles together bit by bit, piece by piece, like a giant game of space Lego. Rocky bits, icy chunks, and gassy wisps all started to clump. These clumps grew bigger and bigger, and their own gravity got stronger. This meant they could pull in even more material. As our disk spun, it created a force pushing outward, balancing gravity's inward pull. This balance allowed material to stay in orbit around the forming sun. Different regions of the disk started to take on different characters. Close to the sun, it was hot, so only rocky and metallic materials could survive there. Further out, it was cooler, allowing ice and gas to stick around. This is why we have rocky planets like Earth near the sun, and gas giants like Jupiter further out. It's all about location, location, location. Let's zoom in on the region where Earth would form. Here we see countless small objects called planetesimals. They're like cosmic building blocks, some as small as pebbles, others as big as mountains. As these planetesimals smashed into each other, they stuck together. Many of these collisions were violent, but with each collision, a larger body formed. This process is called accretion. It's how our Earth grew from tiny specks to a full-sized planet. Scientists think a collision with another planet-sized object gave us our moon. The heat was so intense that Earth became a molten ball. This molten state allowed heavier materials to sink to the center and lighter materials to rise to the surface. Section 4. Earth's internal makeover. Layering up. Now let's dive deep into Earth's makeover. Remember that molten ball? Well, it didn't stay a uniform mix for long. As Earth spun, heavier elements like iron and nickel sank to the center, forming Earth's core. It's like the yolk of a cosmic egg. Around this core, other materials arranged themselves based on their density. Lighter materials rose towards the surface. This process is called differentiation. It's like a cosmic sorting machine. Heavy stuff goes down, light stuff comes up. This layering gave Earth its distinct internal structure. At the center, we have the inner core, solid and incredibly hot. Around that is the outer core, liquid and made mostly of iron. This is where Earth's magnetic field comes from. Next comes the mantle, thick and mostly solid but can flow slowly over time. Finally, we reach the crust, the layer we live on. It's the thinnest layer, but it's crucial for life. The crust formed as Earth cooled. It's like the skin that forms on top of cooling pudding. Section 5. Water and life. Setting the stage for existence. Now let's talk about something we all need: water. Earth didn't start out as the blue marble we know today. Water came from impacts with icy comets and water-rich asteroids. These impacts delivered water, filling Earth's basins and forming oceans. Water shaped our planet's climate and atmosphere. Volcanic eruptions replaced hydrogen and helium with carbon dioxide, water vapor, and nitrogen. This new atmosphere, combined with liquid water, set the stage for life. In early Earth's harsh environment, complex molecules formed. These molecules led to the first living organisms. From cosmic dust to a thriving biosphere, Earth's story is truly epic.